We're now going to turn our attention to part 2 of our discussion on key transforming operators that are defined in RxJava's single class. These operators can be used to transform the values and/or types that are emitted by a single. And we'll be talking about the flatMap and flatMapObservables in this part of the lesson. The flatMap operator can be used to transform the item that's emitted by a single. Typically, this is done asynchronously, though it doesn't have to be. The parameter that's passed is a function that's dynamically bound to the new single, and it returns the value that's emitted by the new single. As I mentioned earlier, you can use flatMap to transform the value by itself. You could transform the type by itself, or you could transform both the value and the type. So it's a very powerful, very flexible operator. Here's an example we'll be taking a look at when we get to the case study that's at the end of this lesson. This particular case study uses the single flatMap operator to asynchronously multiply a random big fraction by a large constant. And the goal here of using flatMap is to avoid nested singles. And we'll take a look at what those would look like in just a moment. In this particular example, you can see that we first use the make big fraction async factory method to asynchronously create a very large big fraction. And we get back a single to it, which is kind of like a future. And then when that computation is finished, once we've created the big fraction asynchronously, we then use the flatMap operator on the BFS1 single to then take the results of that asynchronous creation and then multiply that big fraction by a big, large, constant big fraction and do that asynchronously as well. And by using flatMap, we ensure that the return result is a single to a big fraction. In contrast, if we were to use the map operator instead of using flatMap, then we'd end up with nested singles. So we'd have a single to a single of big fractions, which is not nearly as concise, and it's more verbose and kind of awkward and weird to look at. So flatMap can help to de-nest these otherwise nested uses of singles. Project Reactor has a flatMap operator in its mono class that works the same way that the RxJava flatMap works for its single class. And both of these methods work very similarly to the then compose method that's defined in the Java completable futures framework. Let's now turn our attention to the flatMapObservable operator, which is basically used in a more generalized way to return an observable from something that starts out as a single. So we can see here that this particular operator is used to transform the item that's emitted by this single into a publisher. And the parameter that's passed in there is a function that produces a sequence of R, where R is the parameterized type that we're dealing with for this particular operator. Therefore, what gets returned is an observable that receives the emissions. And we'll talk more about observable, of course, later when we get to the observable part of the course. As I mentioned, for flatMap, flatMapObservable also can be used to either transform the value by itself or transform the type by itself, or transform both the value and the type. So it's very flexible in that regard. Here's an example that we'll also take a look at when we get to the observable part of the course. This example is used to concurrently multiply the result of an asynchronous single operation by all the observable results when all of the asynchronous operations complete. So basically what happens here is we use the fromArray factory method operator to get ourselves an observable to a big fraction, which is a bunch of big fractions. Then we use the fromCallable operator to get ourselves a single to a big fraction. Let's assume for sake of argument that could be done asynchronously. And then when that asynchronous computation completes, we use flatMapObservable to take every of the items that is emitted by the observable, and then we go ahead and we multiply each observable by the item that was emitted by the single. So what we end up with when we're all done is essentially an observable that contains the results of multiplying the results of the single by all the results of the original set of observables that came back from the array. So a very powerful way of going kind of from one to many, if you will. Project Reactor has a mono class that has a flatMap many operator that works in much the same way as we see for RxJava's flatMapObservable. And that's basically the end of our discussion of key transforming operators in the single class in RxJava.